At the very bottom of the world, beyond the crowded continents and the familiar rhythms of human civilization, lies a land that seems to belong to another planet. Antarctica emerges on the horizon as a kingdom of ice and silence, a place where nature speaks not through forests or rivers, but through the slow movement of glaciers and the distant roar of cracking ice. Here, the landscape stretches endlessly in every direction, an ocean of white meeting a sky of pale blue. Mountains rise from beneath ancient ice sheets like forgotten monuments, their peaks carved by millions of years of wind and snow. The air itself feels different. It is colder, sharper, and astonishingly clear. On calm days, a silence settles over the continent, so profound that it seems to absorb every sound. Yet Antarctica is far from lifeless. Beneath its frozen surface, powerful forces are constantly at work. Massive glaciers creep toward the sea. Icebergs the size of cities break away and begin long journeys across the Southern Ocean. Fierce storms sweep across the ice with incredible speed, reminding all who venture here that this is one of the harshest environments on Earth. For months at a time, darkness covers the continent. Then the sun returns, circling the horizon without setting, casting a golden glow across endless fields of snow. In winter, brilliant auroras dance overhead, painting the polar sky with waves of green and violet light. This is a place that has challenged explorers, inspired scientists, and captured the imagination of generations. A continent of extremes, where survival is a daily triumph and where some of Earth's greatest mysteries remain locked beneath kilometers of ice. Antarctica is more than a frozen wilderness. It is a living archive of our planet's history, a guardian of ancient secrets, and one of the last truly untouched frontiers on Earth. To understand Antarctica, one must first appreciate its immense scale. Covering roughly 14 million square kilometers, it is larger than both Europe and Australia. Centered on the South Pole and surrounded by the icy waters of the Southern Ocean, Antarctica occupies a unique position on the globe. It is the coldest, driest, and windiest continent on Earth, yet beneath its frozen surface lies a landscape of remarkable complexity. From satellite images, Antarctica appears as a vast white expanse. Nearly 98% of the continent is covered by ice, creating the impression of a featureless wilderness. In reality, the ice conceals towering mountain ranges, deep valleys, ancient lakes, and even active volcanoes. The continent is divided into two major regions, East Antarctica and West Antarctica. Separating them is the Trans-Antarctic mountain range, a massive chain stretching more than 3,500 kilometers across the continent. East Antarctica forms a larger portion and rests upon some of the oldest continental rock on Earth. This region is geologically stable and has remained relatively unchanged for millions of years. West Antarctica, however, is younger and more dynamic. Much of its bedrock lies below sea level, hidden beneath enormous ice sheets. The origins of Antarctica stretch back hundreds of millions of years. Long before it became a frozen continent, Antarctica was part of a giant supercontinent known as Gondwana. This ancient landmass included present-day South America, Africa, India, Australia, and Madagascar. Fossil evidence discovered across these continents reveals that they were once connected. Similar plant species, ancient forests, and even dinosaur remains have been found in regions now separated by vast oceans. During the age of Gondwana, Antarctica was dramatically different from the icy world we know today. The climate was warmer. Forests covered large areas of the landscape, and rivers flowed through valleys now buried beneath kilometers of ice. Dinosaurs roamed these lands during the Mesozoic era, thriving in an environment that experienced long periods of seasonal darkness, but remained far milder than modern Antarctica. The transformation began as tectonic forces slowly pulled Gondwana apart. Over tens of millions of years, the continents drifted away from one another. Antarctica gradually migrated southward toward its present position around the South Pole. The most important change occurred approximately 34 million years ago, when Antarctica became completely separated from South America. This separation allowed the formation of the Antarctic Circumpolar Current, a powerful ocean current that circles the continent uninterrupted. Acting like a vast moat of cold water, it isolated Antarctica from warmer ocean currents farther north. As a result, temperatures fell dramatically, snowfall accumulated, and massive ice sheets began to grow. Over millions of years, These ice sheets expanded into the colossal frozen blanket that now covers nearly the entire continent. In some places, the ice exceeds 4 kilometers in thickness. The weight of this ice is so immense that it has pushed parts of the continent's crust downward beneath sea level. Yet Antarctica remains geologically active. One of its most remarkable features is Mount Erebus, an active volcano located on Ross Island. Rising nearly 3,800 meters above sea level, it contains one of the few persistent lava lakes on Earth. Its presence serves as a reminder that beneath Antarctica's frozen exterior, powerful geological forces continue to shape the continent. Scientists have also discovered hundreds of hidden lakes beneath the ice. Among them is Lake Vostok, one of the largest subglacial lakes on Earth. Buried beneath nearly 4 kilometers of ice, it has remained isolated from the outside world for perhaps millions of years. Researchers believe these hidden environments may contain unique forms of microbial life, offering clues about how life might survive in extreme conditions elsewhere in the universe. Today, Antarctica stands as a continent forged by ancient tectonic movements, shaped by powerful ocean currents, and preserved beneath an immense layer of ice. Its geological history is not merely the story of a frozen land, but the story of Earth's changing climate, shifting continents, and the extraordinary forces that continue to reshape our planet. If Antarctica's landscape is defined by ice, its identity is defined by climate. No other place on Earth experiences environmental extremes on the same scale. It is the coldest, driest, highest, and windiest continent on the planet, a frozen realm where nature pushes the limits of what life can endure. The most famous feature of Antarctica's climate is its extraordinary cold. Temperatures in the continent's interior regularly fall below minus 60 degrees Celsius during winter, while the coldest temperature ever recorded on Earth was measured on the East Antarctic Plateau, reaching nearly minus 90 degrees Celsius. Such conditions are difficult to comprehend. Metal becomes brittle, exposed skin can freeze within minutes, and ordinary machinery often struggles to function. Several factors combine to create this intense cold. Antarctica's position around the South Pole means it receives far less solar energy than other regions of the world. During winter, the sun disappears completely for months, plunging the continent into a long polar night. Even during summer, sunlight strikes the surface at a shallow angle, limiting its warming effect. Elevation also plays a critical role. Antarctica is the highest continent on Earth, with an average elevation exceeding 2,000 meters. Much of this height comes from the enormous ice sheet covering the land. As elevation increases, temperatures naturally decrease, making the already cold environment even more severe. The continent's brilliant white surface further reinforces the cold. Ice and snow reflect most incoming sunlight back into space, preventing significant warming. This phenomenon, known as the albedo effect, helps maintain Antarctica's frozen state year after year. Surprisingly, Antarctica is also considered a desert. Although it contains roughly 70% of the world's fresh water, very little precipitation actually falls across much of the continent. In some interior regions, annual snowfall is lower than rainfall totals recorded in the Sahara Desert. The extreme cold limits the atmosphere's ability to hold moisture, resulting in exceptionally dry conditions. Wind adds another layer of intensity. Some of the strongest winds on Earth occur here. As cold, dense air forms over the elevated interior, gravity pulls it downslope toward the coast. These powerful katabatic winds can exceed 300 kilometers per hour, creating blizzards that transform the landscape into a swirling wall of snow. Visibility can disappear entirely, leaving explorers and researchers surrounded by a featureless white void. Seasonal changes are equally dramatic. During summer, the sun remains above the horizon for 24 hours a day, bathing the continent in continuous daylight. In winter, darkness returns and dominates for months. Under these long nights, the skies often come alive with spectacular auroras, shimmering curtains of green, purple, and red light dancing across the heavens. Yet Antarctica is not uniform. Coastal regions, particularly the Antarctic Peninsula, experience relatively milder conditions. Temperatures occasionally rise above freezing during summer, allowing seasonal melting and supporting a greater diversity of wildlife. These areas have also shown some of the most noticeable signs of recent climatic change. The climate of Antarctica is both beautiful and unforgiving. It shapes every glacier, every ecosystem, and every human endeavor on the continent. To understand Antarctica is to understand a world governed by cold, wind, and ice on a scale found nowhere else on Earth. At the heart of Antarctica lies one of the greatest accumulations of ice in the history of our planet, covering nearly the entire continent. The Antarctic ice sheet is the largest mass of ice on Earth, a frozen giant that stores approximately 70% of the world's fresh water and nearly 90% of its total ice. This immense ice sheet did not form overnight. Over millions of years, snowfall accumulated layer upon layer. As fresh snow buried older layers, the weight compressed the lower snow into dense glacial ice. The process continued relentlessly, creating an ice blanket that in some places exceeds 4 kilometers in thickness. Although Antarctica often appears motionless, its ice is constantly moving. Under tremendous pressure, glaciers slowly flow outward from the continent's interior toward the coast. The movement is almost imperceptible to the human eye, yet over time these rivers of ice reshape entire landscapes. When glaciers reach the ocean, they often extend onto the water as vast floating platforms known as ice shelves. These shelves can stretch for hundreds of kilometers and act as natural barriers, slowing the movement of inland ice toward the sea. Some of the largest, such as the Ross Ice Shelf and the Filchneron Ice Shelf, are among the most impressive geological features on Earth. Eventually, enormous sections of ice break away from these shelves in a process known as calving. The result is the birth of icebergs, floating mountains of ice that drift through the Southern Ocean. Some Antarctic icebergs are so large they can be seen from space and cover areas greater than entire cities or even small countries. Beneath this frozen world lies an equally remarkable ecosystem. The surrounding Southern Ocean supports one of the most productive marine environments on the planet. During the Antarctic summer, sunlight returns after months of darkness, triggering explosive growth of microscopic plants known as phytoplankton. Though invisible to most observers, these tiny organisms form the foundation of the Antarctic food web. One creature depends on them more than any other: Antarctic krill. These small, shrimp-like animals may appear insignificant, yet they are among the most important species in the Southern Ocean. Krill gather an enormous swarm containing millions of individuals, creating a critical food source for fish, seals, penguins, seabirds, and whales. The entire ecosystem depends upon their abundance. See, ice plays a vital role as well. Far from being lifeless, the underside of sea ice hosts algae and microscopic organisms that provide food for countless marine species. The seasonal expansion and retreat of sea ice influences breeding cycles, migration routes, and feeding opportunities throughout the Antarctic ecosystem. Even beneath the continental ice sheet, life persists. Scientists have discovered microbial communities living in hidden lakes trapped beneath kilometers of ice. These isolated environments, sealed away for perhaps millions of years, have revealed that life can survive in conditions once thought impossible. The Antarctic ecosystem may appear simple compared with tropical rainforests or coral reefs, but it is extraordinarily interconnected. Every glacier, iceberg, current, and microscopic organism contributes to a delicate balance that has evolved over millions of years. In this frozen world, ice is far more than a landscape feature. It is the architect of the environment, the regulator of ecosystems, and the foundation upon which nearly all Antarctic life depends. At first glance, Antarctica appears almost devoid of life. Endless plains of snow stretch toward distant horizons, while glaciers and frozen mountains dominate the landscape. Compared to the lush forests of the tropics or the grasslands of temperate regions, the continent seems barren and inhospitable. Yet beneath this seemingly lifeless exterior exists a remarkable community of organisms that have adapted to one of the harshest environments on Earth. Plant life in Antarctica is limited but surprisingly resilient. The continent's extreme cold, powerful winds, and short growing seasons prevent the growth of trees and most flowering plants. Instead, life clings to existence in the form of mosses, lichens, algae, and microscopic organisms. These hardy species survive on exposed rocky outcrops in coastal areas where snow temporarily melts during summer. Lichens are among the most successful Antarctic organisms. These unique life forms, created through a partnership between fungi and algae, can withstand freezing temperatures, intense ultraviolet radiation, and prolonged periods without water. Some grow so slowly that a patch only a few centimeters wide may be hundreds of years old. The true abundance of Antarctic life is found not on land but in the surrounding ocean. The Southern Ocean teems with life, supported by vast blooms of phytoplankton. These microscopic plants convert sunlight into energy and form the foundation of an ecosystem that sustains some of the world's most extraordinary animals. Among the most iconic inhabitants of Antarctica are penguins. No animal symbolizes the frozen continent more completely. Emperor penguins, the largest of all penguin species, are renowned for their ability to survive the brutal Antarctic winter. During the coldest months of the year, males gather in tightly packed groups while balancing eggs on their feet beneath protective folds of skin. In temperatures that can drop below -40 degrees Celsius, they endure months of darkness and fierce winds to ensure the survival of the next generation. Other species, including Adelie, Gentoo, and chinstrap penguins, form enormous breeding colonies along the coast. During summer, thousands of birds fill the air with calls while tending nests and feeding their young. Seals are another essential part of Antarctic wildlife. Weddell seals spend much of their lives on sea ice, maintaining breathing holes with their teeth. Leopard seals, among Antarctica's top predators, hunt penguins and fish with remarkable speed and agility. Massive southern elephant seals gather in noisy colonies during breeding season, their immense size making them some of the largest seals on Earth. The Southern Ocean also attracts giants. Blue whales, the largest animals ever known to have lived, migrate to Antarctic waters to feed on abundant krill. Humpback whales, minke whales, and orcas follow similar routes, taking advantage of the seasonal explosion of marine life. Above the ocean, seabirds soar across vast distances. Albatrosses glide effortlessly on Antarctic winds, sometimes traveling thousands of kilometers without landing. Petrels and skuas patrol the coastline, scavenging and hunting wherever opportunities arise. What makes Antarctic wildlife truly extraordinary is its ability to thrive under conditions that will be fatal to most living creatures. Thick layers of blubber, dense feathers, specialized blood circulation systems, and complex social behaviors allow these animals to survive where few others can. In Antarctica, life exists not because conditions are easy, but because evolution has crafted extraordinary solutions to extraordinary challenges. Every colony, every migration, and every survival strategy tells a story of adaptation in one of the most demanding environments on Earth. For much of human history, Antarctica existed only in imagination. Ancient geographers believed a vast southern continent must exist to balance the lands of the northern hemisphere. They called this hypothetical land Terra Australis Incognita, the unknown southern land. For centuries it appeared on maps despite the fact that no one had ever seen it. The mystery persisted until the age of exploration. In the 18th century, European navigators pushed farther into the southern oceans than ever before. Among them was the British explorer James Cook, whose voyages transformed understanding of the southern hemisphere. Between 1772 and 1775, Cook crossed the Antarctic Circle and sailed through dangerous seas packed with ice. Although he never sighted the Antarctic mainland, he proved that any southern continent would be extremely difficult to reach. The first confirmed sightings of Antarctica occurred in the early 19th century. Explorers from several nations reported glimpses of icy coastlines emerging through fog and sea ice. These discoveries marked the beginning of humanity's direct relationship with the frozen continent. As the 19th century progressed, expeditions became increasingly ambitious. Scientists, sailors, and adventurers sought to chart coastlines, study wildlife, and uncover the secrets of the mysterious southern land. Yet Antarctica remained largely unexplored, protected by immense distances and some of the most hostile weather conditions on Earth. The dawn of the 20th century ushered in what historians now call the heroic age of Antarctic exploration. This period was characterized by extraordinary courage and determination. Explorers ventured into unknown territory with limited technology, relying on wooden ships, sled dogs, and sheer endurance. Their journeys often pushed the boundaries of human survival. The greatest challenge of all was reaching the South Pole. In 1910, two major expeditions set out with the same goal. One was led by the Norwegian explorer Roald Amundsen, a skilled polar traveler with extensive experience in Arctic environments. The other was led by the British naval officer Robert Falcon Scott, whose expedition combined scientific research with the quest for polar glory. The race became one of the most famous contests in exploration history. Amundsen approached the challenge with meticulous planning, drawing on techniques learned from indigenous Arctic peoples. He relied heavily on sled dogs and carefully selected equipment. His team established supply depots along the route and moved efficiently across the ice. Scott's expedition, though equally determined, faced greater difficulties. His team used a combination of motor sledges, ponies, and human labor to haul supplies across the frozen landscape. Mechanical failures, harsh weather, and logistical challenges slowed their progress. On December 14, 1911, Amundsen and his companions reached the South Pole. After planting the Norwegian flag, they successfully returned to their base, completing one of the greatest achievements in exploration. Scott arrived at the pole on January 17, 1912. There, he discovered evidence that Amundsen had beaten him by more than a month. The disappointment was immense, but the greatest tragedy was yet to come. During the return journey, Scott and his companions encountered severe storms, exhaustion, and dwindling supplies. One by one, the men succumbed to the brutal conditions. Scott's final journal entries, recovered months later, revealed extraordinary courage and determination in the face of certain death. Another legendary figure of the heroic age was Ernest Shackleton. Although he never reached the South Pole, his story became one of the most remarkable survival tales ever recorded. In 1915, his ship Endurance became trapped and eventually crushed by sea ice. Stranded in one of the most remote places on Earth, Shackleton led his crew through months of hardship before completing an astonishing rescue mission that saved every member of the expedition. These explorers transformed Antarctica from a blank space on maps into a place of human achievement, sacrifice, and perseverance. Their stories continue to inspire because they reveal something fundamental about humanity: the desire to venture beyond the known world, even when the risks are immense. The race to the South Pole was more than a competition. It was a chapter in the enduring story of exploration, a testament to courage in the face of isolation, uncertainty, and one of the harshest environments on Earth. In the modern era, Antarctica is no longer a battleground of exploration or territorial ambition. Instead, it has become one of the most important scientific research regions on Earth, a continent dedicated almost entirely to discovery, observation, and cooperation. Dozens of countries maintain permanent or seasonal research stations scattered across the ice. These stations function as isolated scientific communities, where researchers live and work in extreme conditions for months at a time. Cut off from the outside world during winter, they endure long periods of darkness, freezing temperatures, and total isolation while conducting experiments that help explain how our planet works. The foundation of this unique international system is the Antarctic Treaty System, signed in 1959. This historic agreement established Antarctica as a continent devoted to peace and science. It prohibited military activity, banned nuclear testing, and froze territorial claims, ensuring that no single nation could control the region. Instead, Antarctica became a shared scientific space for all humanity. Under this treaty, collaboration replaced competition. Scientists from different countries often work side by side, sharing equipment, data, and logistical support. Research stations such as McMurdo, Amundsen Scott South Pole Station, and many others serve as hubs of global cooperation in one of the most remote environments on Earth. The scientific work conducted in Antarctica spans many disciplines. Glaciologists study the movement and structure of ice sheets. Biologists investigate how life survives in extreme cold. Meteorologists observe weather patterns that influence global systems. Astronomers take advantage of the continent's clear, dry atmosphere to study the universe with exceptional clarity. One of the most important aspects of Antarctic research is its role in understanding Earth's past and future climate. Ice cores drilled from deep within the ice sheet contain layers of ancient snowfall, each one preserving tiny bubbles of trapped air. These bubbles act as time capsules, allowing scientists to reconstruct atmospheric conditions from hundreds of thousands of years ago. Antarctica also serves as a natural laboratory for studying isolation and adaptation. Life in research stations mimics conditions of space missions, making it useful for testing how humans might survive on other planets. Through international cooperation, Antarctica has become more than a frozen continent. It is a symbol of what humanity can achieve when nations work together in pursuit of knowledge rather than conflict. Antarctica plays a central role in shaping and revealing Earth's climate system, though it may seem remote and disconnected from everyday life. The processes occurring here influence weather patterns, sea levels, and global temperatures across the entire planet. One of Antarctica's most valuable contributions to science lies hidden beneath its surface: ice cores. As snow falls year after year, it compresses into layers of ice. Each layer preserves tiny bubbles of ancient atmosphere, effectively trapping snapshots of Earth's past climate. By drilling deep into the ice sheet, scientists can travel back in time, sometimes more than 800,000 years. These ice cores reveal patterns of natural climate change, including cycles of warming and cooling long before human influence. They also show dramatic shifts in greenhouse gas concentrations, volcanic eruptions, and changes in atmospheric composition. This information helps scientists understand how Earth's climate system responds to different forces. Antarctica also plays an active role in regulating the global ocean system. Cold, dense water formed around the continent sinks into the deep ocean, driving a global circulation system known as thermohaline circulation. This process redistributes heat around the planet and influences climate in regions far from the poles. Changes in Antarctica, therefore, have worldwide consequences. When ice sheets lose mass, global sea levels rise. When sea ice patterns shift, ecosystems across the Southern Ocean are affected. Even subtle changes in Antarctic currents can influence weather systems thousands of kilometers away. In recent decades, scientists have observed concerning changes in parts of Antarctica, particularly in the West Antarctic ice sheet and the Antarctic Peninsula. Rising temperatures and shifting ocean currents have contributed to ice shelf weakening and increased glacier movement in some areas. Because of its sensitivity and global impact, Antarctica functions as an early warning system for climate change. It responds slowly but powerfully, reflecting long-term trends that affect the entire planet. By studying Antarctica, scientists gain not only a record of Earth's climatic past, but also critical insight into its future. Despite its isolation, Antarctica is no longer untouched by global change. The frozen continent, once believed to be permanently stable, is now experiencing measurable transformations driven by a warming planet. One of the most visible challenges is the loss of ice. In parts of West Antarctica and the Antarctic Peninsula, glaciers and ice shelves have shown signs of thinning and retreat. When ice shelves weaken or collapse, they no longer act as barriers holding back inland glaciers. As a result, ice flows more rapidly into the ocean, contributing to rising sea levels worldwide. Warmer ocean currents are also reaching further south than before, slowly eroding ice from below. This hidden melting process is especially dangerous because it occurs out of sight beneath floating ice shelves. Over time, it can destabilize entire glacier systems. Changes in sea ice are equally significant. Seasonal sea ice expands and contracts each year, but recent observations show shifts in its extent and duration. These changes affect the entire Antarctic food web, particularly species like krill, penguins, and seals that depend on stable ice conditions for breeding and feeding. Human activity adds additional pressure. While Antarctica has no permanent population, increasing numbers of tourists visit its coastal regions each year. Scientific stations also require fuel, infrastructure, and logistics, all of which must be carefully managed to minimize environmental impact. Fishing in surrounding waters, especially for krill, is tightly regulated but remains a growing concern. Pollution and invasive species, though limited compared to other continents, are still potential risks. Even small disruptions in such a fragile ecosystem can have long-term consequences. The future of Antarctica is closely tied to global climate decisions. Because the continent responds slowly but powerfully to temperature changes, it acts as both a warning system and a long-term indicator of Earth's environmental health. The stability of its ice sheets will play a major role in determining future sea level rise across the planet. Protecting Antarctica is not only about preserving a remote wilderness, it is about safeguarding a critical component of Earth's climate system, one that influences weather, oceans, and ecosystems worldwide. Antarctica is more than a place on a map. It is a world shaped by extremes, where silence stretches across endless ice, and time seems to move differently beneath frozen skies. It is a continent that preserves Earth's past within its glaciers, reflects its present through shifting ice and storms, and hints at its future through subtle but powerful changes. Few humans will ever set foot in its deepest interior, yet its influence reaches every coastline and every climate system on the planet. It stands as a reminder of both the fragility and the resilience of Earth's natural balance. In its vast whiteness, Antarctica holds a quiet message that even in the most remote corners of the world, everything is connected,